Hi, everyone, and welcome to Unit 7 and 7.1, Solving Systems of Equations by Graphing. Our ICANN statement reads, I can find the solution to a system of equations by graphing. So what we're going to do today is we're going to learn how to graph two different equations and find what it means to be a solution to both of those equations. So the first thing that we want to do is we want to make sure that we have our calculator up and running so that we can go ahead and graph these points, if that is something that you ordinarily use. So let's go ahead and open it up. Now that we have our calculator available to go ahead and make our points for the graph, I'm going to go ahead and plug in the first equation into the y equals function. At this point, you want to hit second graph in order to get your points. And then you're going to go ahead and put your points into the table that you have. After you have your points in, you can go ahead and repeat the same process for the second equation. Now that we have our points from both equations, it's time to graph them. So in order to make a point on the graph, what I'm going to use is I'm going to go ahead and take a circle out of here in order to make sure I have a good point or a good shape for a point. In order to make sure it stays as a circle, what you want to do is hold the shift button, then click, and then make your point. At this point, you can go ahead and fill in the color, anything that you want it to be. I'm going to go ahead and make it red. And then since I have 4 points in my table, I'm going to go ahead and make 4 red points. Then what I'm going to do is go ahead and simply drag those points to where they're supposed to be. Now that you have your points where they want to be, make sure that you go ahead and connect them with the line. The line function, you're going to click, and then you're going to click on the first point and drag it to the last point. And then if you want it to fill the entire graph, you're going to go ahead and follow the same pattern so that it goes through all the points. At this point, what you want to do is also extend it in the same direction. And then you have your line from the first equation. Now make sure that you put an arrow on both ends, and you can do that by clicking on the end line over here. So at end line, I'm going to make an arrow, and also at the start. At this point, what you want to do is you want to make sure that you label this line. So we're going to go ahead and create a text box and make it up here. And then we're going to label it y equals negative 3x plus 6. After you have your first line, we're going to repeat the same process for the second line. Now that I have my points on the graph for the second equation, I'm going to once again, connect all of the points on this line by starting at the first point and dragging it through the second point. Make sure that your line is crossing through every point that you have on the graph. Then for the same direction, you're going to go ahead and drag it through. And then you have your second line. Don't forget to put arrows on both ends. And then also create a text box in order to label the second function. At this point, what you should notice is that both lines have intersected with each other at this certain point. This is what we call the solution to a system of linear equations. So what I'm going to do is just go ahead and write down the point of intersection, which is 2, 0. Another way you can identify the point of intersection is you'll notice in our table of values that both the tables share a point. So I'm going to go ahead and just highlight that in yellow so that you guys understand which point is the solution to a system of linear equations. Similarly, if you want, you can go ahead into your calculator and try to find both those points so you know what the solution is, but make sure you are creating the graph so that you understand how to do that too. Okay, let's move on to example 2. So in example 2, I'm going to repeat the exact same process. So I'm going to go ahead and grab my calculator, and I'm going to go ahead and type in the first equation that I see, and then I'm going to go ahead and make the points. Now what we're going to do is we're going to repeat the same process for the second equation and go ahead and write y equals 2x plus 4. And go ahead, hit second graph, and then make your list of points again. It would be ideal if you could get some negatives and some positives from the graph, and obviously you can't graph any points that fall outside of the 10 boundary. So we're going to go ahead and just make our points, and we're going to go from -2 to 2. Now that we have our table once again, we're going to go ahead and make a point for our first line, and then we're going to duplicate it to make 4. This time, well, I just use the color green. Why not? I'll do that for my first equation this time. Then I'm going to go ahead and drag it over to the points that I have over here. At this point, once again, what we're going to do is make a line through the 4 points, and then I'm going to go ahead and extend it all the way through here, just so that I have everything in the pattern set. And I'm going to do the same thing in the opposite direction. Now that we have our first line, don't forget it once again to make the arrows on both ends, and then use the text box to label the equation. What I'd like you to do now is go ahead and pause the video and create your line for the second equation using the points and the instructions we have done before. So take a minute and go ahead and graph those points. Okay, so at this point what you should notice is that we have the line crossing over here, and although it's not perfect, you should be able to draw a point over this, and this would be your point of intersection. What this means is that the point of intersection here is going to be -4, -4. So I'm going to go ahead and type that over here. And there you have it. We have found the solution to both of the systems of linear equations. Now it's time to move on to example 3. In example 3, what you should notice is that equation 1 is going to be a normal graph that we are going to make before, but equation 2 is not yet in slope-intercept form. So in order to convert this equation into slope-intercept form, we're going to have to solve for y, which means that what I'm going to have to do is either go ahead and make this on the slide or grab some scrap paper so I can convert it into the correct equation. So let's go ahead and go through that. So once again, what we're trying to do is we're trying to solve for y in order to complete this into y equals mx plus b4. So what I'm going to do is I'm going to start by subtracting 4x from both sides. And what you should remember is that since this does not share an x with the other value, that means they are not like terms, which means I'm going to go ahead and write these next to each other. And then I'm going to bring down the 2y. At this point, what I need to do is I need to divide by 2 for all 3 terms in order to finish converting it into slope-intercept form. This is going to cancel. -4 divided by 2 is -2, and then -2 divided by 2 is just -1. So there you have it. We have our second equation now in slope-intercept form, and then we can go ahead and graph. Okay, now that we have our second equation converted into slope-intercept form, what you're going to do is you're going to go ahead and you're going to type it into this equation 2 slot that I put in for you guys. And this is going to be the new system you're going to graph. What we're going to ask you to do at this point is to complete this graph on your own, in addition to the final assignment that's in here. Now, to finish off, what I want you guys to do is take a look at this stained glass project that we're going to have you guys do, and that is going to be done in a separate video. So I will go ahead and let you guys start off with that, and then I will attach a separate video for the stained glass video. So take care of everyone, and you have just completed your first video project with Google Slides in 7.1. Take care.